Now the other two is kind of geeky, but it's a bonus from my end here, and it could be tricky. For that, let me just explain you the target over here. So I want to find out the quarterly sales. So Jan, Feb, March makes one quarter. So I need the number over here for the sum of these three. So that should be something like sum and these three. We have this here. And then again, it's April, May, June. We need here. And then July, August, September. We need here. December. And here. So you see, it's just the quarterly sales. It's least concerned about if it is June, it's only showing about the last 3 months and not for Jan to June. This is a different target or a different objective that we have for this particular row, and it's only taking a sum of last 3 months. And we need to ensure that it's not calculating the score for, or rather the total sales for the last 3 months in any of the cells in the middle. For example, August. If you select the last 3 months, it's not one quarter by a financial calculator or going by the calculator, because the quarter starts from, your calendar starts from January and hence it's the 3 quarters here. Right now, August is falling somewhere in the middle of a quarter. That is not helping. So how do I get this? Let me show you. I'll clear this off. Now, before we proceed further, we need to first identify which months should we have the result appearing in. And quarterly sales, when you say quarterly, let me add just one more column over here. I say insert. Now that's quite a long column here. Let me just shrink this to this much. And here I would mention quarterly. How many months do we have in a quarter? It's 3 months. So there is an interesting function called as GCD, that's greatest common divisor. Now what exactly this happens, let me tell you that. Okay, first let me get the result and I'll explain you. For those who are not very comfortable with arithmetic or mathematics, I'll explain that in a moment. For now, I want to know the greatest common divisor. GCD is the greatest common divisor between two numbers. So 1, it's this. And let me log the column reference here, comma, the month number of the current month. Close bracket, you have this. Now let me expand this formula ahead and show you what exactly is happening here. So 1, 1, 3, 1, 1, 3, 1, 1, 3, and so on. And notice something over here. Every time it's the last month of the quarter, we have a number 3 in place here. Right? So this acts as a good measure or a good way to identify the month when the GCD is 3, only then calculate the last 3 months total. Otherwise, don't calculate, just leave it. That's exactly what we'll be doing. Okay, now before that, let me just explain you the concept of this GCD function. Now in arithmetics, we would have studied about greatest common divisor. What does that mean? Now this is 1, the month number. Okay, it's Jan, right? We have the month function. It's January. These are months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then again 1, 2, 3. So what exactly is happening here? 3. 3 can be divided by 1 as well as by 3. 3 can be divided by 1 and 3. But in case of January, it's number 1 as the month number. So 1 can be divided by number 1 itself. Now here again, if you were to take a GCD of 3 and 2, 3 can be divided by 1 and 3, we know that, and 2 can be divided by 1 and 2. Now what is common over here? The common divisor in this list, it's 1. So 1 is the answer over here, that's the common divisor. Again, what is common in these two? 1 can divide 3 and 1 can divide 2, so 1 is common here. Now what about this? 3 and 3, so 3 can be divided by 1 and 3. And this particular month number, which is also 3, can be divided by 1 and 3. Now, which are the common numbers here? 1 and 3. And which of them is the greatest? It's number 3. So we have this here. Similarly, we have April, which is number 4, and 4 can be divided by 1. It can be divided by 2 as well as 4. Now let me put this down. This is the month divisor over here. This is a month divisor, and this is the divisors of 3. So we have 4, which can be divided by 1, 2 as well as by 4. But when it comes to 3, it's 1 and 3. That's it. So which are the common numbers in both these? It's 1. So we have this 1 here. Now moving on, it's 1 and 3 again. This will be consistent across for all of them because we are just looking at divisors of 3. 3 can be divided by 1 and 3 only. But now when it comes to May, that's number 5. So 5 can be divided by 1 and number 5 itself. So what is common? It's 1. Now 6 can be divided by 1, 2 and 3. And what is common over here? We have 1 as well as 3. But which of them is the greatest? It's 3. So that is the reason we say GCD, which is greatest common divisor. So all these are divisors, and amongst them the greatest is number 3 in this list. It can be divided, but 1 as well as 3 can divide it. That's number 6 for June and number 3. But the greatest of the lot is number 3. Hence, 3 is the answer. So when we applied GCD over here, the GCD function, it just took the greatest of the common multiples or the common divisors here, and we have this result here. So we have 1, 1, 3, that's matching. Again, 1, 1, 3, that's exactly matching, and it will go on. So this is the logic applied over here, and we get this result. How do I apply this? Let me show you. So I say if GCD of number 3, because it's a quarterly, and in a quarter we have 3 months. Let me lock the column over here. And then month, that's the current month number. We are in January, so that's current month number. Close bracket, equals to 3. That is, the GCD value is equal to 3. Only then use the sum function, and under that you have the offset function. We take, here we are, so we take this as the reference point, and under this we say 0. Don't move by any number of rows and don't move by any number of columns. Let the height be 1 and width be minus whatever quarterly, the time span that you have, and again lock the column here. This is minus 3, but we are using the reference here. We have this. Now close this bracket for the innermost offset function and then close the bracket for sum function. Well, in case if the GCD equals 3, we can execute this sum function, but what if it's not equal to 3? I would just put double quotes here, a pair of double quotes, which means blank cell. Close the if function and you have this. Now I copy this function all the way to the right, and here we have this. Let me show you what's happening here. If GCD of this number 3 and the month number, current month number, is equal to 3, only then take a sum of this, whatever selected within the offset function. That's here. From here, don't go anywhere from this purple cell. The height is 1 and move left or select cells towards the left, but the width is 3. And if you don't find it, if it's not equal to 3, then just leave a blank cell here with double quotes. And that's it. We have it here. Now this is slightly a notch above, but that's an interesting one here we have. Try the same thing for half yearly sales. Now for half yearly sales, it's 6. Okay, it's 6 months in half a year. So this time instead of 3, 3, 3, okay, we have 3 over here. Let's try this with 6. So we need the divisors of 6 and the month divisors. Let me just clear this off, or rather let me just change this with the blue cell with the 6. So that means the GCD of number 6 and the current month number. We hit enter and copy the formula to the right, and you see 1, 2, 3, 2, 1, 6. 1, 2, 3, 2, 1, 6. So here we have 6 over here twice. That's 2 half a years. How did this happen? Well, what are the divisors of 6? It's 1, 2, 3, and number 6, of course. So 1, 2, 3, and 6 is constant across because we are referring to divisors of 6. What about the month divisor for January? It's 1. What about February? It's 1 and 2. And March, it's 1 and 3. 4, it's April. That's month number 4. So 1, 2, 4. May, it's 1 and 5. June, it's 1, 2, 3, and 6. Why? Because it's month of June and that's 6. That should be the same.